Chaos.
Yes, chaos. That's what we can expect today.
Yes.
No, Stephen, you're banned. Oh, that's really, really bad. Okay, so...
World.
Iggy, g'day everybody. I know this is a totally random start to it because we were just sitting here chatting and I pressed the button to go live and it all kind of happened. So today in the studio, we have Seon
In the lab.
and Kean.
Hey, Ron.
G'day. Hopefully everybody can hear us. Ken has sound? You do? Good. Thanks, Peter. Anyway, the guys arrived and we started talking about stuff. And the thing is that we've been talking about things that we should have been talking about on the stream.
We can redo it.
So
Get it better this time. Get it right this time.
yeah.
Hopefully.
This is the
We'll
edited
make things
version.
up anyway.
Yeah. What were we just talking about? No, we're talking about ATEMs, but that's not very
that's
interesting
right.
for the stream.
No.
Yeah.
No.
Well, okay. Well, Seon, you've been on the stream before, but Kean has not.
Yep.
So I think a really good thing would be, Kean, could you introduce yourself and talk about the sorts of things you do?
Yep.
Yeah.
So I started off in electronics pretty much as a teenager, and kind of started around making lights that blinked and stuff like that, and then got into kind of playing with TRS-80s at the local Radio Shack. Really got into computers, and so at high school I built my first Z80 based computer.
Cool. Yep.
That was about 1983, I think.
Yeah. Did you read the Talking Electronics magazines?
I think, was it Talking Electronics out then? Yeah, probably about
It was
then.
around that time, yeah.
So I had a few sources of influence, but I pretty much just gave it a go and to see what happened.
Yeah.
And I knew some people who worked in the electronics industry. They weren't like mentors or anything, but they gave me leftover bits and pieces. Okay, so they'll brush off all the crap on their bench into a box and give it to me, and I'll do things with it.
Yeah.
So that's how I accumulate. Because I had no pocket money, so I basically had to rely on that.
Yeah.
And so I moved into. So I started university, but I never finished it, and I moved into.
It's a running thing.
Yeah, it is.
Running thing.
You are one of us.
I started twice.
Same.
Okay.
Same course.
Electrical engineering
Twice.
and computer science.
Just robotics twice.
Okay. I was so I started electrical engineering and then had to get a job.
Got to eat somehow. Got to eat somehow.
Got to eat somehow. So I got a job with a cash register company, which was owned by National Semiconductor, which is kind of interesting.
Hang on a second. That's just Kean's natural voice. He echoes when he talks.
It's like someone turned up the reverb.
At least I don't sound like Dave Jones.
Oh. Too soon.
So I got a job doing repair work, and over a couple of years I moved into like senior technician and then software guy and project manager, and I was kind of sick of that because now as a project manager I wasn't doing any electronics, and so I left that company and I went to work with my two brothers in a software company as the hardware guy, and I ended up becoming a director of that company. I was there for about 18 years. And at the end of 2007, we sold that business and I started just as a consultant. And so since 2008, I've been consulting, both doing IT stuff and embedded systems. And I've just picked up random clients over the years. I've still got some, well, it's,
Hey mate, do some hardware?
well, it's actually true. So it's been word of mouth, but like one of my first clients, I was looking at commercial office space because I started off working at home, and I quickly realised I really need something better. And not far from where I have my office space now, I was looking at a place, and it was actually, now that I look at things, it was really cheap. It was actually for sale, and I wish I'd been able to buy it.
Yeah,
but I went there, met the real estate agent, and it turned out he actually had someone else there for a viewing, which was really weird. Like for the real estate agent to have two different people coming in at the same time.
Well, it's to show that there is demand and push up the price.
Well,
Maybe.
I kind of drummed up a chat, talking to them, and it turned out they were in the electronics industry, and they were doing beverage dispensing systems. And I said, I do embedded systems, I do programming and stuff. And they ended up bringing me on as a consultant for their project. Cool. So, like,
who got the place?
Random people in the street.
Did they buy the place as well?
No, they didn't.
Oh,
No. And they ended up going broke.
Oh.
But I got paid.
Because your fees were too high?
No. But the project actually went really well.
Okay.
But, like a lot of things, they ran out of money, or they had the money pulled by backers before they could actually go into production.
So they didn't have enough runway to
Yeah.
become profitable, and yeah.
Yeah, well, I think it's always it's the thing. The people who are providing money don't understand the technical stuff, and they often, when you hit road bumps,
Yep. It freaks them out.
it freaks them out.
Yep.
And even though you're kind of so close to we actually had a working system. We actually showed it at trade shows, but they basically pulled out.
It's really common just when you get through the whole product development stage and you're just about to go into a mass production, that the finances they get cold feet at that point, because that's when it's like all in, no turning back, right? Where the money really has to go in, and so many products die at that point just because lack of understanding or vision from the people putting the money in.
Yeah. So you end up with products that have got right to the point where you got pre-production samples.
Yep.
And it never goes ahead.
Yeah.
So no other reason than fear, right?
Yeah. So over the years, I've just built lots of small embedded systems. None of them really aimed at going commercial production or stuff. But now I do that. So I've got clients in a few spaces. Like I do a lot of work with wildlife monitoring, and I do a few projects in the building lighting space. I've done a few projects for Vivid Sydney, which is like the colour light show stuff. So I've worked with a couple of clients on that. I've done products for the catering industry, for like the food health and safety kind of stuff, with barcode scanning and temperature probes and stuff like that. I've done control systems for industrial processes, helicopter engine.
It's really specific
stuff.
and focused stuff, right?
But also very broad.
Yeah, I do stuff with PLC programming. It's just, it goes on and on. So I do a lot of stuff at the moment with GPS trackers, and it is. I'm very much what I would consider a generalist. I'm not an expert at any particular area, but being quite generally experienced, I can kind of dive into any area and research that topic. Like we've been talking a lot about RF. I'm not an RF expert, but I have a bunch of RF tools, and I've kind of taught myself bits and pieces. And experimented, and so I have a vague idea of what I'm talking about. Yeah,
and the interesting thing about that is that you can put it in context because you have experience in other areas.
Yes.
So you'll be learning about RF in the context of the bigger project.
Because I do PCB design, I've done firmware, I've done architecture for big accounting software systems. So I'm used to doing a lot of integration between systems. That's if anything, my specialities are troubleshooting and integration, making things work together.
Okay.
That's a bit about me.
Well, you mentioned wildlife tracking.
Yes.
And one thing I know that you've worked on is the penguin. Is it RFID and weight tracking for the penguins they're in Victoria, aren't they?
So I've done projects with wildlife tracking, just GPS trackers for wallabies and possums, basically collars. So with the wallabies, because we can have a heavier tracker, we use a GSM or 3G kind of upload to a website I built.
Which of course means lots of power, which means batteries and all of those things.
And we got some trackers from, I think they came from a Taiwan supplier, and we got custom firmware from them, and then I modified them a little bit because they sold them in a kind of a box, and we had to take them out of the box, and they had to add extra antenna wires and battery connections and stuff.
Mm-hmm.
Their firmware had bugs, and so if there was poor reception, it would end up not going back to sleep.
Okay.
And of course, wallabies tend to, especially on Phillip Island, which is where we were doing that study, they'll often get into like hollows in logs and
okay,
and
into black spots where no coverage.
And so some of them, the battery life was like over a month, and other ones it would be like a week and a half.
Mm-hmm. Yeah.
So that was okay. I often work with universities and PhD students who are kind of, and they want to collect data, and then like, as part of their PhD, they're kind of writing reports and analysing the data and stuff like that.
Yeah.
So the same with possums. We did a similar thing. And it's just a smaller tracker, and they have to collect the device afterwards, and it logs all the data on an SD card. So you get much better battery life.
Yeah. There's no radio involved.
No radio involved. And with those, we also did barometric readings, so we could actually track how high they were going into trees and stuff, and temperature logging as well. That's not so useful. And then I've done a similar project using the same trackers for brumbies, which are the wild horses that cause a lot of damage in alpine Victoria. So just doing a migration study and seeing where they're going, and just getting some hard facts on their movements to kind of deal with the control.
Decision could be made.
Correct. So I don't get involved in. So all these projects with animals involve like a ethics committee. So they have to approve. How big the tracker is, how it's used, how much it weighs.
Yeah.
So I'm after you. I'm watching the chat. I thought I'd do John a favour and actually watch the chat in case there's any comments that I can interrupt.
Yes.
Make it go so you know where the GP is when they lose the trackers.
Correct.
Yeah.
So I'm hoping to do. So I've had a few discussions about doing koala tracking, and that's a project which I think will work really well with Laura.
Okay. Yep.
Because we only need to get a position. They don't move.
No, they're quite.
They can move several kilometres in a day, but they tend to stay in the one spot, like the one tree, for ages. And so we only need to position maybe once an hour, and we can put in our own base stations, because these will all be remote locations.
Yeah.
Dodgy wants to know how do you track the brumbies without tagging them?
I guess you do tag them, don't you?
Yeah. I didn't actually get involved in the actual mounting the
physically attaching.
They have handlers. So they have the research people, and then they have the handlers who deal with the animals. So with the brumbies, they put a bridle on it, and then they mount it. And so I actually custom designed a 3D printed housing, which was kind of like curved,
so that it wouldn't snag on things.
And the 3D printed the circuit board sat in the middle, and then we had two batteries, one on each side, so it kind of was balanced weight, and then it had mounting points so they could put cable ties or whatever through to attach it to the bridle, and it actually had thumb screws so they could actually unscrew like a waterproof sealed cover to get inside to charge it and stuff.
Okay, that's cool.
I've always wanted to use like the smartwatch magnetic pogo pin things and have USB connection through them. I never got the USB connection working properly on the STM32 that I was using, so they just take out their SD card, and that's a lot easier for the end users anyway. But it'd be nice if they didn't have to open the unit up to do that.
While you're talking, I'm going to grab something there.
So Wagon Load wants to know, can you do wireless charging of the trackers when they're in the burrows? Distance for wireless charging is too far. Like
you could, but
really close.
So what they often do with the animals is they put out baits with cages, and so they put out carrots, for example, for the wallabies, with pills in them. And so they'd go back later and they'd find a sleepy wallaby. Very happy sleepy wallaby. And the problem is that they get the same wallabies like the carrots and the drugs so much they'll keep coming back. And so they'll go back the next day and they'll find the same one which has already got a collar on it. But again, this all goes through the ethics committee. I don't get involved in any of that. I deal with the researchers. So you could, if you knew like if you were working with a particular animal that you knew that they lived in a particular burrow or something like that, yes, you could do that.
Is that magnetic?
It's quite a
Yeah,
challenge.
but it's only charging. So
Okay.
this is
That's the round one.
yeah.
But you can get these
You can
ones
get
with 4 or 5
the longer
pins.
ones
Yeah.
as well. Yeah.
And I've got a bunch of them.
But have you seen how much the waterproof ones are?
The ones I've got, they're not cheap, but
Oh,
these are... So I don't need it to be waterproof enough because I'm
submersion.
not
I'm not
permanently
doing
on there.
submerged.
Right,
Yeah.
okay.
So some of the people I've worked with have done platypus way bridges, which is a really strange...
And-
How do you do a platypus way bridge?
Yeah.
I think that was at one of the zoos. So yeah, each animal has its own complexities.
Yes.
Okay, because they're the way they live. So in Phillip Island, where we have the little penguins, which are only they're the smallest penguins. They're only about 1.5 kilos each. We have weighbridge systems. So actually, as they come and go each day from the ocean to their burrows, and they tend to have the same burrow they go back to, and it can be quite a long way from the ocean. It's like surprising how far they waddle.
Okay.
Got to get their exercise somehow.
They've got to get their exercise. So they go across a weighing platform, and we weigh them 50 times a second. They sometimes pause as they go across, but if they go straight across, it only takes about a second. So we get 50 weights,
Yep.
and it's what's called dynamic weighing.
Yes, I was
So-
going to ask about this because it's not a static mass.
Correct.
It's going.
You
The
can't-
force is going to be varying all over the
You
place. as
can't
they
tell
walk.
them stop, hold.
Yeah. You have a little gate that
Really?
comes down.
We've talked about having gates,
Yeah.
but then they'll just try to climb over it, and then
Yeah.
their weights would
And
vary.
they'll keep moving anyway. They're not going to sit
Correct.
still.
And can you imagine like a next one?
Ethics committee.
Chop them in half. So, and you also get like they're very timid because they're very afraid of predators, and when they when they come out from the ocean, they're like very careful, checking, and then they'll run across the beach and like get into a safe area. And so on Phillip Island, they've had massive problems with foxes, but they've pretty much eradicated the foxes.
Okay.
So that's made the populations increase. So that's actually quite a good population of penguins, I believe, at the moment. So yeah, we have a few different colonies. They've got. What am I looking at?
Michael, you're banned too.
As a service.
As a service. Everything is as a service.
Yeah.
Okay.
So, Kean, you're talking about dynamic weighing.
Yes.
I've never had to do something like that, and it sounds kind of tricky. So, how do you is that a software problem, basically?
It's mostly a data filtering problem, and the bigger problem is actually like you can basically take the weights. Like if you graph it, you'll tend to when they step onto the platform, you'll see a increase from 0 up, and then it will kind of bounce around, and you can actually see their footsteps pretty much.
Oh,
Okay.
You can
nice.
actually tell how fast they're moving.
Yeah.
And then it drops down. So what you need to do is clean off those tails,
Yep,
which
so you
obviously
bracket
affect bracket
the data.
it, and make sure that there's no huge steps. And then you just average that and work out the standard deviation, and you have a good idea.
Okay.
Assuming the temperature is perfectly stable.
We'll get to that.
Oh, okay. So there's a complication here that.
And this is
talked
why I'm
about
here.
previously.
Yeah.
This
Yeah.
way.
And we have a couple of problems. One is they sometimes bunch up and they try to go across the platform because we want as much data as we can.
3 penguins in a trench coat.
So we have a long weighing
This
area.
is so good.
I think it's about 0.5 metre long, but narrow that they walk through.
Okay.
And so
So
sometimes
it's like a
you get
funnel.
2 of them kind of climbing over each other or kind of bunching up. And so that requires extra filtration of the data. We don't need really accurate weights. Like we don't need high precision. What we want to do is track their weights over time. And you can also, because we're reading the microchip, so we've got an antenna above
Yep.
them as they go under the...
So you're identifying
They go through a
the
tunnel,
individual.
effectively,
Yeah, and then matching the weight data to the individual.
because you can match the weight to them coming in from the ocean when they often have food. Okay, they've eaten or they've got actually a belly
Or they're
food.
carrying it.
Because they regurgitate the food
I see.
to feed the chicks.
Yes.
Okay. Or their partner if their partner's kind of sitting on eggs. So, and then you can weigh them when they leave again, and you can actually see that. And they're looking at patterns over time. So they have people who, focus on the data analysis. I don't really get too involved in that. I've written some code for them, but they got people who do write stuff in R. The statistics calculation. Yeah.
Yep.
So I don't have to deal with that.
Yeah.
Which is good.
Yeah. As long as you provide them accurate data.
As long as we provide accurate data. So we've got the initial development of the dynamic weighing system, it's been done for years, but this particular project was done by the Australian Antarctic Division, and they built these weigh bridges for use in Antarctica. And as the Australian Antarctic Division retired old equipment, they donated it to Phillip Island researchers. And so they've been reusing that old equipment. And they've been running at least one weigh bridge, I think, more than 20 years. So they've got heaps of historical data for one of the colonies.
Yeah.
And then we got some extra equipment from the Antarctic Division, and I built another system. And then we had to put in what we call the pen glue, which is because it's a very windy area on the coast. So we had to put in this wind rated kind of sloping shack with the solar panels and the batteries. And then we run 48 volts down the hill. It's nearly 100 metres down the hill to where the actual weigh bridge is. Okay. It's a very steep hill, and they climb up this hill.
They get about 4 volts at the end of the run. The voltage drop across
the system can run off it's designed to run off 12 volts nominal, but can handle high and low. And so we've got a DC converter to handle that. And we actually run quite a heavy, the typical solar kind of heavy cable.
Grade cable.
Yeah, so there's, that was a little bit of overkill.
Just doesn't have picks up voltage going down the hill.
Electrons fall down the wire.
The problem is pushing them back up again. Because they've got to go round.
Yeah.
And then obviously we run Ethernet. And then we have, for the people who come in, because you can't get mobile reception there either. Right. So you're kind of in a valley on the edge of the island, and so we have like a Wi-Fi access point there for the researchers, because they go at least once a week. They go and recalibrate the weigh bridges, check them, clean them, because they get built up with sand blowing in and stuff.
Conditions. I can just imagine whatever I build having sand thrown all over it. It's not going to be good.
Yeah. So these systems that Antarctic Division built run, I think it's called Pengos. So it's a custom task operating system, real-time operating system they developed, and it's running on like a PC 104 80188 I think board.
Yep.
And then it's got like a whole lot of serial ports. And then serial ports talking to the weighing platform, serial port talking to the RFID reader, serial port talking back to the comms, and so we've got a few spare parts to maintain them, except for the interface for the weigh bridge platforms. The Maxim parts for that long obsolete. Yeah. So one of the first things I did, apart from the first thing I did was build them some portable RFID readers. That was the first project I did with them. Because they go around to the burrows, separate from the weigh bridges, they go around to like a count and check the burrows, look for eggs, look for chicks and stuff.
So how deep are the burrows?
Not that deep, and they actually they have a lot of man-made ones.
Okay.
So they're like boxes.
Access is pretty good.
Yeah. So they can lift the lid off the box and see inside, and they try not to disturb them too much. But they've got these readers, which I make, and the main thing is they actually have a keypad, because a lot of the readers that a vet would use, all they do is got a display on. They just read the microchip and display. Just reads out a number. Some of them can log data, but what I've done is it actually prompts them for a whole lot of data. Like they measure the beak length, they enter the number of chicks. Okay. And other stuff. Yeah.
So being the RFID reader is just one function of it. It's more like a data collection
whole device. Data collection system. And so they used to write all this stuff on notepads, and then it would rain, and then they'd have to try and decipher their messy writing.
And also you've got to correlate the handwritten notes to the RFID readings and everything.
Well, they don't need to now.
Yeah.
I think I've built about a dozen of these readers for them.
Thanks, Iggy. I feel like I'm in a tennis match.
Yeah.
It's good. It's good.
So then I took over maintenance of the existing weighbridge, and one of the things I wanted to do was what happens with the existing software, which was written like 20 plus years ago, is once it reads the microchip, so it turns on the antenna to read the microchip to save power. It only turns that on once it detects weight on the platform.
Okay. Yeah.
Turns on the reader. Once it reads the microchip, turns off the reader. Then it continues weighing until the weight's left the platform. And the problem is that they have more than one penguin sometimes crossing. In that one weight kind of period. And so what I did was...
Joe got really fat all of a sudden. Doubled
in size.
I added a Linux computer, which is quite appropriate, that logs all the raw data. So the existing system they had only collected like the final average weight and standard deviation. I added a Linux computer that logs all the data going between the weighbridge platform and the...
so you can reprocess it if you have to.
Correct. And they do. And it also collects all the RFID reading, and it also collects all the user interaction, like when people log in and do calibrations. So we get a complete record of all the calibration data in that log as well. And so we can go back and run scripts through that and parse all that out. And then what I added was a little, so I use MSP 430s for a bunch of these projects. I added a little, basically a box that sat in the middle between the control box, which I didn't want to change the code on that because they've been using the same code for more than 20 years.
Keep it stable, don't disrupt anything.
And I didn't want to break it, so I added a box that intercepts the messages between that controller and the RFID reader. And what it does is it makes the controller think it's turned off the antenna. And all it does is intercepts that message and stops any new tags that have been read being sent back, because we don't want to confuse that system.
Because it's not expecting to see a reading.
Correct, but we can still record them on the logger. So I've added a bunch of hardware without changing the system too much.
Sounds very much like modding a car with
exactly.
Like
it is.
An ECU interposer.
And
faking the inputs.
And then I designed a new weighbridge interface for the load cells, and I used a Texas Instruments ADS 1232, I think it is, which is a really nice 24-bit ADC intended for like Wheatstone bridge type applications. So in this case, that's what a load cell is. And so we have 4 50 kilogram load cells connected together into a summing box and then connected to the load cell converter interface. And then that spits out serial data.
So 50 kilograms per corner?
Yes.
For a 1 kilogram.
For a...
1.5
sorry, 1.8, yeah.
No.
So...
but you can have multiple penguins at once.
Right, and people might step on it.
Okay.
Right.
People could step on it, and they actually have, because it's like a 1/2 metre by 1/2 metre, it actually has a big aluminium plate which weighs like 6 kilos or something.
Okay.
And you have to tear all that out. But it was designed for king penguins in Antarctica, which I think can weigh...
Yeah, they can be really big.
10 or something kilos, I'm not sure. They can be pretty big. And of course you can get more than one penguin trying to cross at once. So I designed that load cell interface. I actually tried it. I did an interim one, just using a HX711. I don't know if you've come across them.
Yeah, I've used those.
And it worked, but it was...
They're kind of crappy.
Pretty crappy.
Yeah, I've used those in the zero deflection joystick project.
Okay.
And ended up switching to an NAU something or other. I can't remember.
There's often people like sending... Because I contributed a bit to the Arduino library for that. And so I often get people asking me questions. But they work okay, but we wanted something a bit better. So that was just an interim solution, because we had some units die. And so I then designed a complete new one, and I basically did it off the reference design and then added a 80 mega. The advantage being that we can run Arduino code on it, and the Linux computer that talks to it can actually run Arduino CLI.
Oh, of course, and then
and so I can remotely
you can
update the firmware, refresh it,
yeah,
which is pretty cool. And so I've now built a complete new system of my own design, and it built into like a Pelican case.
Yep.
And uses all waterproof connectors and stuff. And so I've sold a few of them. So we've got one weighbridge system of my design, the third weighbridge down at Phillip Island, which I installed about last year when we had a break in the COVID lockdowns. I got down here and installed that. We've also got one for wallabies, endangered species of wallabies up in Queensland. And then I've got a couple of them in New Zealand, but they don't have weighing platforms. They're just logging the RFID.
Yep.
So, yeah.
You said a Pelican case for penguins.
Yep.
Yeah.
Yes. And one of the biggest problems we've actually had is like rats eating cables.
Wow.
And the other big problem is solar power. So dealing with like typical problems in the field.
I would have thought salt corrosion would have been
yeah.
a big problem.
That was one of the things I spent a day on this trip.
Yeah.
The existing systems there are in like stainless steel, kind of like, you know, the electrical cabinets or control cabinets you have in a factory.
Oh, right, yes.
And they're showing a bit of signs, you know, of corrosion after 20 years, but they're still solid.
Yeah.
They're still solid.
That's okay.
But the locks were totally corroded, and because the locks weren't closing properly, the seal of the box wasn't of the door was closing.
Yeah.
And so we're getting some sand and ants and corrosion happening on the inside. The electronics was all still working fine. So I actually spent some time. I actually ordered some new locks from RS on Wednesday just before 5 p.m.
Yeah.
And I had them down on the island just early afternoon the next day.
That's amazing.
That is amazing. Like, because I post stuff down to Phillip Island and it takes like 4 days.
Yeah.
So I was very happy, and I managed to drill out the old locks and put new ones in. So I get to do like some that maintenance
but that
stuff
shouldn't
as well.
be you doing that.
That shouldn't be. No.
Yeah.
Because these systems are looked after by me and the research team, and we're trying to get the kind of facilities management people more involved in that kind of stuff. They've got a new facilities management person, so hopefully we'll be able to have them doing, like, the researchers have to clean solar panels and stuff like that, because you get a lot of bird droppings on them.
Yeah. So, well, that raises an interesting question, which is, who runs all of this? So how is it being funded?
Yep.
I know that there are volunteers who go down and help out with all of this as well, but there are obviously out-of-pocket expenses. So what is the group that runs it?
Before I answer that question, what's the name of your favourite penguin? Yours wants to know. Are they named? Do they name them?
Sandy.
Sandy. Okay.
Sandy is a jar of sand.
Right. Okay.
With a thing in it, and I think it's 1.2
It's
kilos.
a calibrated
and that's a
jar of
calibration standard.
Okay. Okay. No names. No penguin names.
I did not actually see any live penguins on this trip. I saw lots of the ones in display, the stuffed ones.
Yeah.
But I've actually gone out at night and sat near the weighbridge and actually watched, which is actually quite a nice experience.
Sure.
But you get bored very quickly and very cold.
So I didn't mean to hijack your question. Back to who runs it? Who funds it? Who runs it?
So there is the funding. So they have a research team who obviously get paid. I don't know that's through government grants and stuff. They have a lot of students come through, and so they've got PhD funding. I don't know how that works either.
Yeah,
there's something called
projects.
there's something called the Penguin Foundation, which take donations, and they fund all the special research projects. So the stuff like I do, the weighbridges and stuff, is generally paid for through the Penguin Foundation. And this latest weighbridge system was actually funded by the Bank of Melbourne, because the Bank of Melbourne have recently done some advertising with penguins in, I don't know if you've seen them.
I can't remember.
Okay.
I might have.
So they have this penguin walking through, and he's looking for a drop. It's actually quite a weird ad. It's on YouTube. It's quite clever though, and so my some of my family members actually went to the Bank of Melbourne yesterday, and they actually were given a little penguin money box, which is really cute. So that's how they're funded. I've donated some of the funds I've made on other projects. I've donated back to that in the past.
Yep.
There's some really good suggestions. You should write all these down and give them to the team over there, right? Like they could.
Not sure if I want to read them.
Turn the solar panels into water slides for the penguins, and they can clean them as they slide down them.
So
Iggy said the reason.
That's clever.
Iggy said the reason you didn't see any penguins this trip is because they all got electrocuted by the cables that the rats chewed.
Right.
So
no, we fixed that problem. Yeah. The other problem is snakes.
Ooh, okay. I'm never going to visit.
And the Penguin's actually got a number of redbacks in it, so I don't go in there now.
Oh really? Oh god. Everyone, there's no snakes and spiders in Australia.
No.
It's all fine.
No.
It's all fine. It's not a dangerous place to live.
Just the drop bears.
Just drop bears. And skyhooks everywhere. Yep.
Yeah, so this trip, I had to come down because there was a few maintenance issues. But one of the big problems is the system hasn't been logging data properly. The newest system we put in last year hasn't been logging data properly.
Yep.
And it's been...
Asking how long it hasn't been logging data properly.
Since last year. Okay.
And with COVID and lockdowns and everything, it's been just difficult to come down.
Yeah.
And then, as soon as lockdown stopped, I got really busy with work. And so the problem was we were seeing phantom waits kind of all through the day. And sometimes there'd be more than a couple of kilos. So it turned out that there was some... So we've got these summing boxes to keep the 4 load cells together.
Yeah.
And we switched to new summing boxes because sometimes the systems get flooded with water in heavy rain and the load cells get damaged. Like they're stainless steel and they're kind of sealed with silicone and stuff, but they still get ruined.
Yeah.
And they're precise, like, resistance devices. So they have to replace these load cells reasonably regularly. And they were all soldered kind of connections in the past, which are reliable but really hard for maintenance.
Yeah.
So we put in summing boxes with screw terminals, which I bought. But they had potentiometers on them for doing, fine adjustment. It turns out that those potentiometers had incredibly bad temperature coefficients.
Oh, okay.
So
they were just drifting all over the place.
They were drifting all over the place. And so as the sun would come past and then the cloud would change... So it wasn't just ramping up during the day and then down again at night. It was going all over the place.
And then wind goes this way and then wind goes that way.
Yeah, the wind. You get some really strong winds there, and so that would be cooling, and then you get the sun back out, and that would heat it up. And like we ended up doing all this troubleshooting. We got hot air gun and trying to diagnose because we thought it was either a mechanical issue with something like the metal expanding and contracting with heat or something, because you've got 4 load cells. You can imagine if the metal either moves or expands, it puts sideways forces on the load cells. Like the load cells have like a ball connection, so it's kind of got a bit of play in it. But we're trying to track down where the problem was, and then we finally realised that it might be the summing boxes. So I just basically desoldered all them, put in shorts, and we ran some more tests, and they were great.
Yeah.
So hopefully I don't get called back. But it was just really difficult to troubleshoot. Yeah. Especially remotely.
Yes. Yeah. Well, things that change over time, like you got to be there at the right moment that the sun changes or a cloud goes past or something, and you go, hang on, that was correlated to that.
I was convinced it was wind. And because you get wind blowing, and because we tear out any weight on the platform every minute, and so because you get sand blowing in, and occasionally you get sticks, and sometimes you get animals crawling through there. Other animals other than penguins.
Which reminds me of
Other than penguins, snakes, spiders, rats.
Dodgy asked, how do you put the tags on the snakes?
Super glue.
Super glue.
Yep.
Okay. So there is actually a serious answer to that, that question. Yes, super glue is how you put tags on snakes.
I had some researchers who work with snakes who I've talked to. We didn't end up doing it, but they were actually interested in my really small tracker. Because I got this one with battery, it's only a few grams, but it's very limited battery life.
Yeah,
very limited in what you can do, and of course
7 seconds.
You've got to collect it again, which is a difficult thing.
Hey snake, come here, give it back to me.
Very hard with snakes.
Stay still, snake. I need to super glue off you.
You got to put out the rats to bait them, I guess, or something. Yeah. Yes, no. When they actually have these,
and you got to imagine the conversations that the wildlife people, like who deal with the snakes or whatever else, would just generally have in their day-to-day office, right? The conversations about how they're going to trap a snake and tag a snake.
It's all normal for them. It's really weird when you come in as an outsider.
Yeah. Bizarre.
So they actually have these dive loggers that they actually put on the penguins, and they actually can track them as they go out to sea and dive, and they've got GPS and pressure logging and stuff.
Yep.
And so they super glue them on. Yeah. So
how long do they stay on when they're super glued? It's presumably like skin sloughs off and things like that.
Feathers, I guess.
Feathers, yeah.
So I don't know, but they sometimes lose them. Yeah. So sometimes they don't recover and these are quite expensive. I don't make them.
Yeah.
They're quite specialised. So.
You could think they could make little like vests and jackety things that they can put them in on the penguins. I mean, it works in the movies. Why can't they do that?
They've got all these like knitted vests that get donated for the penguins when the penguins get like the oil.
Yeah.
Get trapped in oil.
Yeah, and they need to be cleaned.
And they need to be cleaned, and then they put these little
knitted
vests on.
Little grannies sitting around there knitting. Sorry.
And what size penguin is this one for? Yeah.
Yep. So one of the researchers I work with in New Zealand did a race. So he's got Patreon supporters, and so one of the penguins was called Kean.
Yeah.
And so we were doing a race to see who would get back first. So that's down in like southern New Zealand, and it's Milford Sound or somewhere like that. And so they go out for several days and then come back, and they travel quite long distances. Yeah. Anyway, that's me talking too much. So.
No, that's the whole point of what you're here for.
Yep.
It looks like this is, full of jokes today. Why did Bob go to the bottom of the ocean and stay there? I don't know if I want to know the answer. Dodgy, what are you getting at? Yes. Hey, Cable Tie. Steve Tracker, come on, people. Yes, Peter, we need a Steve Tracker. He's hang on, if I move that way, there. He's just over my shoulder.
Steve never goes anywhere interesting.
No.
Always hanging around.
He's always just here.
Yeah.
Yeah.
You know who Steve is?
Yes.
Okay.
Steve the squirrel.
Steve McKean. Kean, Steve.
Hello. I'm in a weird mood. I've been up since 4 o'clock this morning. So.
Yeah, so you were up at 4 o'clock. You're doing assembly at the moment. You're doing a production.
Rework.
I'm doing some rework.
So, you said that you had some huge number of boards that needed rework. Is that because something went wrong in the production?
No, that's because, well... I don't know.
You don't know where to start the story.
You got to think about how you're going to word this.
I got to think about how I'm going to word this because I don't want to throw anyone under the bus.
Okay.
And you'll work out who the anyone is.
There's not too many
shortly.
people.
Yeah, shortly. So there is an issue with all of my ESP32S3 boards that I've made. Varying degrees of issue, and it's not affecting everyone. And it's not affecting every board. So it's taken me. I found out about this. Was it about 10 days ago now?
So you've been shipping S3 boards for a little while, haven't you?
I've been shipping I've shipped about 1,600 boards so far, and had just finished building 1,200 boards to go out to resellers. So Adafruit, Amazon people, and more boards for Pomeroni. Pomeroni have already got some.
Yep.
I've had to stop shipping, tell Primaroni to stop selling, till I could work out what the problem is. And which has been frustrating, really, really frustrating. And right now, I don't specifically know what the problem is, because there's some really oddities with the S3 chip compared to the S2 chip and previous chips. And even the dev kit that I've got, the official dev kit, underperforms compared to an S2 chip when it comes to Wi-Fi. Bluetooth seems to be okay, but not Wi-Fi. Espressive say there's nothing wrong with the PHY, there's nothing wrong with the calibration. They're happy with it. The hardware design guide for the S3 chip is kind of full on when it comes to the RF section now. And they insist on adding a secondary filter for, a filter at the end of the matching network for secondary harmonics, to suppress secondary harmonics, which has only ever been a suggestion on the S2. I've never seen one added on an S2, even the modules, right? And whatever.
It's never been a problem
now. Never been a problem. So it's a so I don't know exactly what the problem is, but I've managed to resolve it with the RF matching network, kind of. So I dug myself into a hole with the matching network I implemented on my boards. I put an L network on, which should be sufficient, but I put the wrong direction L network on. I put the right one on for what I thought I was doing with the matching, which is taking 50 ohm coming in and moving it to 30J0. But it turns out it's not really 30J0 I need to match against. What I need to match against is insert random number here.
Does it vary per chip?
It varies it varies greatly depending on the PCB that the chip goes on.
Oh.
And this is undocumented. And I only found this out from Espressive after challenging them about what's going on, because I started getting these random people saying, hey, I've got an S3 board, Feather S3, and I can't connect to Wi-Fi. I've got a Feather S3, I can connect to Wi-Fi. Okay, well, I've got two Pro S3s, two Feather S3s, one of each works and one of each doesn't. And I'm going, oh my God.
They all passed your test.
And they all passed my test jig. Now, to be fair, my testing now is 100 times more robust than what it was before. And that's on me. I should have been testing more thoroughly. And maybe I could have caught some of these things. Though now I've determined, and so it took me a while to actually get a reproducible issue in my office. And it took me a while to work out, only a couple of days ago, to work out what the difference was. And it seems that on some channels Wi-Fi works and on some channels Wi-Fi doesn't.
Oh, okay.
Now, there's also a problem in the silicon of the S3, which Espressive, which I know about, still undocumented anyway. And I know about because of the pre-certification disaster I just went through. So I kept saying to Espressive, I'm booked in for pre-certification, I need to send my boards, but your RF test tool doesn't work with the S3 chip USB native mode. That's correct, you need to use an external programmer via the UART pins. That's how you need to test it. Why? That doesn't make any sense. You've got you've got a C2C and you've got serial USB JTAG. Why can't I do that? None of my boards have a UART chip on it. Like I'm using a USB, that's the whole point of these chips, they've got native USB. They pushed back, they refused, they pushed back for quite a while, till eventually I found out the reason they're not doing it. So this is not an Espressive bashing conversation, but the reason they're not doing it is there's a silicon bug. The silicon bug is that if you have the native USB enabled, there's anywhere between a 1 point something and 3 dB issue on the radio, and they thought that was going to be a problem for certification, so don't use native USB for certification. Well, they originally thought that it was much bigger. And it's only on channels below channel 9. Surprise, surprise, the majority of people are having issues are on channel 6 or channel 1, right? And they're all using native USB because I've only got native USB on my boards. So, So I just failed pre-certification for FCC and CE because my boards are already there. They actually got stuck in Shenzhen for 6 weeks at the DHL depot when it got there the day they shut it down.
Oh, this is because of the COVID.
Because of COVID
thing.
And 6 weeks before they could get them out. They got them out. We booked it in, and then on the day that it was too late for me to cancel, like I could cancel, but I wouldn't get my money back.
Yeah.
I find out that there's this issue, right? And I thought, you know what, I'm going to let it go through anyway because there might be some interesting data comes out of it, and there was. We'll get to that. Meanwhile, I've been trying to work out how can I fix my current boards, which I've got 1,200 sitting there, and I've got stacks of PCBs like panels and whatever else, and what do I do about going forward? So I've designed new versions of the boards that now have a pi matching network on it. Even though I still only need an L and the reversed L, from now on,
You're covering yourself.
I'm never putting an L
layout
on anymore. For those that aren't aware, a pi is normally like two items in parallel with something in series in the middle. An L is either one half like that or one half like that.
You can also have a T network.
And you can have a T as well, where you've got shunt there and you've got whatever, right? All my boards from now on, no matter what, are going to have a pi. That way I've got full flexibility. But in this particular case, the matching network wasn't great. Turns out though, surprise, surprise, that like my Feather S3, if I take the matching network off and stick a 0 ohm resistor, it's actually almost identically tuned to 30 ohms.
Okay.
So the Feather S3 doesn't even need matching. Like I get an SWR of like 1.16 just on the PCB alone, right? And that's the problem. The PCB itself is so influences the matching network and the RF so much, and my boards are so small that I have no space to give the antenna lots of clearance like you're supposed to have. You look at their test board and their clearance is half the size of my board. I just can't do it, right? So everything about my design interferes with the RF. But so does my tiny Pico and so does my tiny S2, yet both of those work perfectly. Never had an issue. No one's ever said they can't connect to Wi-Fi or Bluetooth or whatever, right? There's just something fundamentally weird about the S3 chip. It's just super sensitive. Something's going on with it.
It's a bit different to the previous one.
It's quite different to the S2 internally, whatever else, and this has been a very, very expensive and frustrating learning opportunity for me.
So they've made some major revision to their hardware
internally.
I'm sure it's quite a different layout. And
and there's a lot of things they've done which would affect it that are good things. Like they try to get like modem sleep working, right, and light sleep much better. So like you could stay connected to Wi-Fi when you're in sleep, and when you wake up again, you don't have to do the whole reconnection thing. Not deep sleep, but like in a modem sleep. There's a lot of things they've added to the chip that should be really cool and will really benefit people, but it's fundamentally changed a lot inside, right? And it's bitten me, and a lot of it was like in terms of my RF knowledge, I know like 1% of
which is more than me,
right? And since then I've doubled it. And now I know 2%, right? I've learned a lot of stuff, and I'm just about to go out and buy myself like a good VNA.
Spend money,
I'm going to spend a lot of money.
That's been one of my dream instruments for a long time.
Right, I'm going to get a VNA that's also SSA, like the spectrum analyzer as well. And then so I failed cert. Thankfully, the conductive emission stuff I passed, like with headroom.
That was expected.
Yeah, that was expected, but after my week, I really thought I was going to fail it.
You thought you failed everything.
But I was thinking, I wonder how things would have progressed had you got if DHL hadn't kind of held up.
Right. Well, I would have known about this a month ago.
Yeah, but you wouldn't have necessarily known it was causing an antenna problem, but you would have known that there...
You would have just had... You
would have known you failed.
I would have known I failed, and I would have retuned. And in the retuning, I would have
discovered the...
Would you have retuned? Would you have just...
I would have spoken more expressive.
You would have panicked.
So what's interesting is there's... At the 2.4 gigahertz range, I should have brought the thing through. At the 2.4 gigahertz range, there's something funny going on. But there's no fail point.
It's still below limits.
Yeah, right? But then at the harmonics steps, like at 4.8 and 9.6, there's a
And 7.2 to some degree.
A little bit 7.2, but that's still they're still under.
Still
but the other two, so they're all under. They're all under.
Or they're just
but one of them is just like if they do the averaging.
I think there was one over, but it depends on horizontal or vertical and FCC versus
red.
Yeah.
So there's definitely something wrong with the harmonics, and I'm hoping that if I fix the 2.4 gigahertz range, even if there's still harmonics, they'll drop. Drop enough that I'll be fine.
It's either got to be a silicon issue,
or
it's got to be the antenna matching.
Right.
So you've probably fixed that problem by fixing the matching.
That's right.
Because you shouldn't be getting like the power levels at those harmonics are higher than at the 2.4 gigahertz.
Doesn't make the principal frequency.
But that makes no sense. Though, right?
It doesn't.
The only thing it could be is hopefully a really bad reflection. But
Reflection,
the boards work. But the boards work, right? They work better now. So basically, I spent the last 3 days reworking every single board, and but before that, I spent days and days and days with a pretty average VNA that turns out gives intentionally wrong results after about a 2.5 hour period of using it. It just all of a sudden goes wacky.
Okay.
And I didn't realise for the first 2 days, things were changing and I was tweaking, and then I'd go and try to validate the board, and all of a sudden, I was on this path, I was getting closer and closer and closer, and then it was uphill.
Yeah.
Right? But nothing changed.
It didn't make any sense.
No. You got to let it cool, got to turn it off, let it cool down, restart the software. When it's cold again, turn it back on, wait an hour and a half till it gets warm again.
Yeah, you got to let it
and then
stabilise.
go again. Right. So
frustrating. So this VNA you're using now, is it yours or did you
it's
borrow
mine. It's a tiny VNA. What is it?
Oh,
mini VNA,
mini
tiny
VNA
plus.
Yeah, little USB things.
Yeah, it was like a $600 VNA.
Yeah.
It's what I originally matched from.
You've used it in the past.
I've used it in the past and it worked. Like I matched my Tiny S2 in it. It's pretty good, right? I think it's a 1.19 SW. I mean, give or take whatever the PCB does, right?
Yeah.
In an ideal match. But I'm going through this thing at the moment where I'm sick and tired of using inadequate tools, right? I was saying to Kean yesterday that I've got this thing where like it's like a you got imposter syndrome and you got all these things. Well, my syndrome, I've got one of, and I've had it my whole life, is a non-deserving thing, right? Like, so for the last year and a half, I've been using a hot air station to rework boards, and there are better tools, right? Like heating up a whole panel to make one little cap, that's 0402 cap, get hot enough to be able to. Right. Well, you just get some tweezers, right? I went out the other day and I bought a JVC Naze, right? Nano tweezers, nano iron. And oh my freaking god! I can fix a part in I can fix a part quicker than I can reach for my hot air station. And I think to myself, 18 months of hot airing parts, I could have saved myself weeks and weeks and weeks of my life. Yeah. Just if I would have bought that tool earlier. Yeah. Right. And it's the same with this VNA. Like I can, even now that I know about this quirk, like I'm sick and tired of just
There's a much bigger learning curve though with the VNA.
I know there is, but it's all a black box, right? I've got this
you just
Java software that doesn't
on.
even work on one of my Macs because of the wrong Java version.
I wasn't even going to try and explain to you how they work internally.
Right. Oh, well, that's what I was looking at this morning. I learned all about standing waves and how they work and reflection and how they affected. Yep. And it was great. Anyway, I'm learning way too much about
learning is great, but
not
when it's in a situation where something is broken and you're desperately trying to fix it and you have to learn in order to fix it.
Right. And you're stressed.
That's stressful.
And you don't know which way you're going. Yeah. And so I'm going to invest in some better tools and some better learning. And make some decisions where, again, I'm never going to put inadequate matching opportunities on my boards anymore, even if whatever, and never believe what I'm told. If they say it's 30 ohms to match it, pretend it's not.
So one of the things Bruce was asking was, can you measure that?
Well, apparently, with a $27,000 box, you can measure what the actual impedance is on the pin. Without that box, not really. Try to look it up on the internet. How do you measure the impedance at an antenna pin on an MCU? And you get zero results.
So
And,
as I was saying, the only way I can think of to do it is like with the ham radio guy. If I'm not a ham radio amateur kind of guy, but you would typically have your transceiver. You'd have an SWR meter with adjustable dials for your capacitance and inductance, and so you can tune to get the best SWR with your antenna. But that kind of sits between your board, your
adapter this
radio,
and
your antenna on the roof,
or a dummy load or something.
It's a bit hard to do
so
that.
My whole board, including antenna, is
so you need to insert it
than just the connector that they connect the two things together.
Yeah. Right? But you could rule out, like you could completely ignore all your antenna and matching network, and just connect something like that directly into the pigtail going to the ESP chip.
Right.
But you need something that can operate in 2.4 gigahertz. And most of those devices are for amateur radio bands, which are way lower.
Yeah.
So, look, I'm sure there's...
That is an ATU, not an SWR meter.
Okay. Automatic. Well, it's an automatic tuning unit with an SWR meter in it.
Yeah.
Right,
okay. Yeah. So anyway, the moral of the story is I'm going to have to be replacing a lot of people's boards. Not everyone's affected, and if you've got an affected board, let me know. I got no way of identifying if a board is affected or isn't, right?
Yep.
And I got some boards that work some days and don't work the other days.
One of the other things that was mentioned on here,
Yep.
Which mostly affects your nano, but to some degree it affects your others, is as soon as someone puts one of your boards into their own design, and if they mount it on another circuit board,
changes the characteristics.
It can change the characteristics. So they need to be very careful about putting any copper or metal in the area of the antenna.
Right, I have a clearance area around that which people ignore. Right, that's fine.
Yeah, just like with the
or putting into a metal
they've
box.
got a clearance area according to the data sheet.
Right, but
people just put them straight in the middle of the PCB with stuff all around it.
It completely changes the attenuation of it. Right. Do you have a piece? I'm just going to grab
piece of paper?
No, one of those. I just want to hold a piece of paper. So the problem, the problem with the 2.4 gigahertz range is it's extremely sensitive, right? Like it's such a small wavelength, right? And so
it's also quite low power.
Right, but it's not the power though. The thing is so when you plug a board in, right, and like you're doing it, whatever, like Wi-Fi, and it's like this, you get a particular level of power and the attenuation of the radio, of the antenna and everything else. And then if you just go like this, it's different. And you go like this is different, and you go like that is different, and then you go like this is different, and you go like that is different, like different. You know what I mean? So and then you take into account someone plugs it in, they stick it on their desk. They go, great, okay. Does the Wi-Fi work? Yep. Is it good? Maybe. What's around it? Okay. Then they move it over here. Then down over here. Then they stick it in a box, or they stick it in a breadboard, right? Or they plug something else into it with really long wires, right? And the wire just happens to wrap around near the antenna. Like everything you do when you touch the board completely changes its characteristics, right? There's no ideal setup. I mean, other than a test lab, right? With $1 million room. Something. That's right. There's no ideal setup.
So I built myself this big aluminium box,
right,
to try and do measurements in, and like I made it long, just to try and do some kind of far field measurements. I wasn't going to make something that could do 3 meters, but I can do like 1.5 meters, and so I can put my device under test at one end. It doesn't block any of the ambient stuff, so I just do. It really
it made no difference.
You put an antenna inside, it still picks up everything as if it was outside the box. So all you got to do is when you're doing any kind of measurement with spectrum analyzer, if you just got to do an ambient level thing. You look for the peaks, and then you go and do your measurements.
Cancel those out.
Now that's not a big deal when if you're connecting the spectrum analyzer directly into the circuit board, or using a VNA directly into the circuit board, you're not really going to pick up ambient stuff.
Yeah, because the signal is so strong coming out of it.
Which is what I'm going to do. That's what I've opted for.
But if you're doing EMC type testing, you're using an antenna. Not only do you have to deal with you've got to know all the calibration data to adjust the readings. Because cables, antennas, amplifiers, they all have different. They don't have a completely flat response across all frequencies. Right. So you have to adjust for all that. So you can't really do calibrated measurements. As I've said to Seon, what you need to do is get a report. So you've got a report now. So you've got a starting point.
Okay. Yep.
And if you can try and reproduce measurements with similar peaks, so you want to see
The values don't really matter.
the values. The absolute values don't matter too much.
Yeah.
If you can reproduce similar peaks
Yep.
at
And
the
then
same same frequencies areas,
Yep.
then you've got a starting point to then fix it.
Yeah, to fix it.
Right.
Yeah.
Yeah. And of course, you know, like the cost just to be able to do that at 2.4 gigahertz is frightening.
Yeah.
Right. The cost of doing it at 7.5 or
Yes, that's right. When you look at those
the
harmonics.
cost of these machines
That's
just get
right.
insane.
A spectrum analyzer that can do 26 gig is quite expensive. Like,
Yes.
that's typically like you can. I think there's some companies that sell like ones that go up to 12, but typically, a lot of the cheaper ones are limited at about. They used to be limited at about 1.5 gig.
Yeah. Now it's about
Now
That's about
3.2
5, I
is the
think.
sweet
Oh,
spot.
3.2, yeah.
And then there's some 5s and 7.5s.
So I'm going to focus at the 2.4, like the
Yeah.
right, and see if I can improve that
Yep.
set of thing, and then if I can, I'm sure I can find someone who can do some testing for me.
But you can pay for a bunch of
That's
testing
Right. That's right.
and still
I
not
could
spend as
go
much money
pre-share
as
three more
buying a
times.
VNA,
That's right,
yeah.
3 more times.
as buying
cheaper
something
than
that can
the
do
difference in price.
7.5
Yeah.
gig. Yeah.
So I never wanted to go this far down the rabbit hole with RF, right? And I've been very lucky up until this point that I haven't needed to. But this has been I don't ever want to go through this again. Like it's been really stressful. Like I've been doing crazy hours.
Right in the early days of LifeX, with the very first units that we're going to go through testing, Mark Alexander hired a VNA. I think he hired it from Tech Rentals or somewhere like that.
Right.
So I remember he had it on his kitchen table at home with the very first LifeX prototypes. Had this huge thing that had to sit there and warm up for ages. And it was a pretty old unit at the time.
Yeah.
It was like a
cheaper to rent.
15, 20-year-old VNA, but yeah, that was what was used for doing the initial characterization on the LifeX prototypes.
Well, at the same time, LifeX were doing their stuff. I was involved in the Morse Cloud startup.
Okay, yeah.
Which was a Linux computer controlling pretty lights and stuff. And I designed all that, and we failed our first testing.
Everyone fails certification first time. Like,
And no, not all my products have, but that one did. And it was purely the power supply. We, against my better kind of judgment, the other people involved had chosen to cost cut on the power supply, and I'd kind of said, I don't think this is going to pass, but we put it through testing. It failed. It failed conducted emissions, so that was noise coming back through the power supply.
Yeah,
because it had like a 5-volt 3-amp power supply, if I remember correctly.
which is a fair amount of power.
It's a fair amount of power, and I'd done a lot of work in the PCB layout to reduce voltage drop and stuff going out to the LED string. So it's just like we tried ferrites and stuff, but starting ferrites to cables, you may as well just spend an extra $1 on the power supply.
Yeah, that's right. It's putting a band-aid on top of it.
Correct. So we bought I actually had some better power supplies, so we swapped it out and we did another scan, and that fixed that problem. And then we went through some more testing, and because we had this long, like 5 meter long LED string with 50 LEDs, and that acts as a massive antenna.
Yeah.
And it worked fine except for one mode, which was like the fastest random, like rainbow, I think it was a rainbow pattern.
it's the digital switching.
All that SPI data.
Yeah.
And the only way to fix it was to add a capacitor on every LED. So every LED regenerates the data signal. And you've got to attenuate the edges.
Oh, okay, on every signal line. Yeah, otherwise
every LED is regenerating that data signal.
Yes.
So these are WS2812s.
Yes.
Yep.
And so every one of them's regenerating the signal, and with sharp edges, and you get the sharp edges cause high frequency because of
You'd think they'd adjust that in the IC. Like there'll be a really common thing that people have to solve on these LEDs. Why not just?
I actually went to World Semi's headquarters
Right.
in China and actually met with them, and I talked to them about that.
Okay.
Right.
And so in future versions of the chip, they have actually put some mitigations in.
Right. Okay.
But the reason I actually went there was because we fixed that problem. The way was to get some people in the factory in China to hand solder
capacitor on every LED.
Thousands and thousands of LED.
Grant just confirmed that
capacitors.
his Moore's cloud has 5 volt 3 amp power supply. Thanks, Grant.
Thanks, Grant. And I can't remember what year that was. 2013.
That was a while ago. Yeah.
I think it was 9 years ago. Or something.
Sounds about that.
Yeah.
About right. Yeah.
So I've got a couple in my office and at home, and I know a bunch of people who've still got them, and I know a few have failed out there. The SD cards could get corrupted, but the most common failure was the power supply, because power supplies, the capacitors heat up and spill their guts and die, and so I've actually repaired them just by replacing the capacitor in them.
No one expects things to last longer than a year these days anyway.
Yeah.
Really?
I maintain stuff that's more than 20 years old. So.
Right. Right. Stuff that was built back then, you'd expect it to last a long time.
Well, the stuff I build now.
Stuff.
Like if I'm building lighting systems for buildings, they've got to have lifetimes of 10 plus years.
Yeah, I'm not talking about that. I'm talking about when people buy LED
consumer
products.
Like the price is just going like this. Like you can't expect it to last very long.
But that was my first design that I'd done, PCB design. I think it was my first full layer board. It's the first one I'd done running Linux, DDR memory, like some high speed stuff going on. Not that advanced compared to today, but and everything apart from the power supply and the LED data signals, it passed it. I was quite pleased with that.
Yeah.
But I went to China mainly because once we actually ramped up production, nothing worked. And it turned out that World Semi had modified the silicon to reduce the area of each die. To do that, they'd reduced the ESD diodes.
Okay.
On the surface area of the ESD diodes. So the ESD diodes couldn't handle as much much current. And so when they were working in the assembly area in the factory, they were blowing them up.
Oh, okay. So they were being blown up in production.
Correct. So I had to go over there.
And it's a typical, here's your stock that you ordered.
Yeah.
No note or remark about any type of change.
No.
On it. Just,
That's right.
Yeah, it's the same one you used last time.
Yeah.
Here you go.
Unfortunately, their data sheets do not get updated as they change things. Yeah, that's even some big companies are pretty crappy at that.
Right. Or they do it really late, like the errata comes out.
But other companies, like I get data like updates. PCNs is what they call them from Microchip, for example. And they send out notifications every time they're going to change anything at the factory. You know, they're going to start building chips in a different factory. They're going to change the plating on the metal and pins and stuff, which none of which really relevant to the kind of production runs I do.
Yeah, but for someone who is really obsessive, they want to know that detail, I'm sure.
You need, like, if it causes some issue down the track, you need to be able to track. Same to Seon.
Trace back to where the change was. Yeah.
With the large manufacturing, like contract manufacturers, they track everything down to the finest detail.
Yes.
Like they'll keep track of the reflow oven temperature profile for every panel that goes through.
Yeah.
And so they can go back, and if there's an issue with boards failing, either during final testing or maybe in the field, they can go back and look at that board,
see if there's some correlation.
and go back and try to correlate that to some process issue, or point the finger at parts suppliers or whatever.
Yeah.
Because obviously, if you have a lot of devices that go out to the field that start failing, you've got to replace them. It can be very expensive.
Yeah. This is going to be for every board I need to replace.
Don't start crying.
It's
please.
3 boards. It's basically I go backwards 3 boards for every board I have to replace. The shipping alone to replace people's boards is like I lose profit of 3 boards.
Yes.
Like this has been really
Painful.
Yeah. I calculate probably about $20,000 this is going to cost me.
And that's not including
my time, not including my time or
the
any equipment
that you have to buy,
or anything. Right? It's a fiasco. But what's interesting is like my Tiny S3 is almost perfectly tuned. Like I think there's one Tiny S3 that's failed so far. That's it, right? It's every board's different because whatever. So I never realised just how much the PCB like influenced, not just like the stack up, but just everything around it, how dramatically it influenced the impedance
matching,
right, for the transmission line. Like it was just, I knew it did, but it's all like theoretical, whatever, you know what I mean? But yeah, it's quite incredible how much it actually.
And when you start dealing with like high-speed signals, and you've got impedance matched pairs running like with FPGAs going to ADCs, running it like something like inside an oscilloscope or a spectrum analyzer or something, which is dealing with this, you actually have to pay the PCB house for impedance matching of the boards.
Yeah.
And they actually test it, so they actually put a test coupon on the edge rail of each board, and they actually test them to make sure that those PCBs pass. Because you don't want to then go and put thousands of dollars worth of parts. Yeah. Especially like FPGAs can be really expensive.
Yeah.
And so you don't want to populate those boards if they're not going to.
Sure.
They're guaranteed to fail testing anyway if the PCB wasn't right.
Yeah.
So Bruce mentioned Bruce Siegel's the one that's got the bad Tiny S3. Bruce, try it with like what Wi-Fi channel was that? Did it fail on? Try setting your Wi-Fi channel to 9 or higher, and let me know if it works, because it seems to be the lower channels only that most of the boards are failing at. Which to me, matching network aside, that's a silicon problem, right? Because if it's a matching network issue, it should be failing across the board, right? It shouldn't be like I'm talking about. Like I can take a board that's got like an original matching network on it, and as I said, channel 6 it'll fail. Channel 9 I can connect to Wi-Fi network in sub 2 seconds from wake up, right? Which is as fast as any ESP32 I've ever tried, right? And I can put it 10 meters away from me in my garage, right? And it still works, fire up an AP and it works fine. But channel 6, dead. Like it won't even initialize the Wi-Fi properly. Just dead. So, you know, that's...
But you can actually see, if you look at your SWR measurements, you can actually see with those badly matched ones that the peak or the best performing area is slightly shifted across. It's more closer to 2.5 gig.
Right, or getting closer to 2.
Which explains why those lower frequency channels are worse.
Absolutely, sure.
Yeah.
So we can actually see that measurement correlating to what you're talking about.
Right.
Which is good. Because that's the hardest bit.
No, right. But then on channel 9, I'm getting through the same testing, I'm getting as good as the ESP32 dev kit.
Yep.
Right. So if it is a bad mismatch and reflection.
But you're getting quite a steep V. So as you move down in
it's
frequency,
not that steep. The antenna's quite.
Well, some of them were
wide. Sorry. I don't know. Okay. Anyway, that's fine.
Well, you're talking about reworking all of these boards.
Yep.
What is it that you're actually doing in the rework?
So on the Pro S3 and the Feather S3, I'm literally taking the matching network off and putting a 0 ohm resistor on.
Bridging it, yeah.
Right, because it actually is super close. Well, it's super close to 30, but 30 isn't my target, but I don't know what is.
Yeah.
Right, and of course, again, I have that problem of, you know, if I tune it to 35 and tune, if I get 5 boards and tune 30, 31, 32, 33, 34, 35, how do I measure them and compare them to which one is better or worse?
Yeah.
Right, because I run it right now and it does this, and I run the same test again, it'll be different without even moving the board, and the same test again, it'll be different, right? So, yeah.
So Mike's asked about testing on different AP channels, but that would be really slow in your test jig.
Oh no, no. Well, no, because I don't test it as an AP. I only connect to. There's no point firing up an AP on it, because then what is going to connect to it?
But you could set up multiple APs and connect to different.
Oh, externally.
The other way around, yeah.
Right, but then I can't put multiple APs in exactly the same location.
No, but you just want to check that you're connecting to an AP on channel 1 and you're connecting to an AP on channel 11 or something.
Right. No. Well, okay. In my case, what I'm doing now is I'm always connecting to channel 6.
Once you've got your matching network sorted out.
Failed.
Yeah, because that's your problem.
Yeah, that's right.
If you've got a tombstone part in the matching network, it's probably not going to work at all.
Right.
And once you've got it matched, you shouldn't have a problem.
That's right. Yeah. So all the boards I'm changing right now, like honestly, they're fine, and I'm like every board now, like I'll test it. Right, and when it's finished testing, I just click the button again and I test it. And it'll now fail the test if connecting to Wi-Fi takes more than whatever the threshold was put on. So it's
Yeah.
not just can I see the network, can I connect to it?
Yeah.
If it takes longer than 3 seconds to connect to it, fail.
Yeah.
Fail the board, for whatever reason, it gets put in a tub.
To be checked later.
Checked later.
Yeah.
I'm not even,
Yeah, with testing, there's always you got to get a balance. Like
Right.
with test coverage versus time.
Yeah.
So you can't afford, especially
No,
if
but
you're building
I'm going annual
thousands
now.
of
Like,
things.
I don't care. Like,
You
I'm
want to be sure
wasting
they
time.
work.
Yeah.
But I don't want to replace someone's board and then
Yes.
hit it afterwards. There's a problem with
Yes.
it. It's not going to happen.
Well, it's not a problem if it's the odd board here and there. It's not good.
I'm not going through all of this.
You don't.
I don't want it to be a Wi-Fi problem. It can be some other problem, but not a Wi-Fi problem.
Yeah. But if you're always going to have the occasional problem, and half the time those are actually going to be the end users blowing things up.
Diodes. Yeah, a lot of blown diodes.
Yeah. Inexperienced users playing with things, and that's part of support, and you've got to build that into your costs.
Yeah.
But you don't want to have thousands of boards going out with a problem. So you've got to get that balance of test coverage, and it becomes
Yeah.
As you
I wasn't
move
testing
into-
the Wi-Fi well enough, and I probably could have found this earlier, right? So that's on me. I'll take that. I thought it was a manufacturing problem. Like for about 3 days, I thought that it was a reflow issue, because I could kind of fix them by just hot airing them.
Yeah.
But it turns out it would connect to a different channel, and it would work. And I didn't see the correlation at that point.
Yeah.
Right? And I go, okay, yeah, I'm fixing these boards. Right? Fixed a whole bunch of them, and then turns out that they still
weren't
didn't
actually
work.
fixed.
Right, yeah. So the Tiny S3, I'm leaving the matching network, just replacing a 2.7 picofarad cap with a 5.5 picofarad cap, which is all it takes to swing it to where it needs to go. But I can still tune better, but I need a different matching network. So yeah.
Yeah.
Maybe at least you don't have massive overcurrent issues like driving LEDs.
Like somebody in the US usually. I don't know what that's referring
I
to.
don't know what that's referring to either.
He's referring to something that we don't know the context.
Yeah.
Yeah.
So it's been fun. It's yeah. It's one of those lessons you learn. You know.
And you took time off to come and hang out with us.
Yeah.
Thank you.
Well, that's why I got up at 4. And
Took a bit of
and work
convincing.
on it. It did.
Yeah.
I was really excited to come here and I'm looking at all the work I need to do and I'm going, but no. This is a once in a lifetime
Cool.
thing, right? Because you won't have to lab here anymore soon.
Well, I'm
That's
driving back
true.
to Sydney tomorrow, hopefully.
Okay.
And I've got a massive amount of work I've
You
got
got
to
a
catch up
backlog.
on. I haven't read my emails in most of this week, so I'm a bit scared to do
That'd be
that.
horrifying.
Yeah, I know, Mike. I got up actually at 3. No, I got up at 4 because it was 5. I started working at 5, so it was at 4.
Whichever way.
Yeah, whatever.
Too early in any case.
Every fruit design. Oops. Okay. I'm staying out of that one.
Yeah.
Yeah. So next week I'll have all my boards back in stock next week, and I'll be shipping to resellers. And no, this coming week. What day is it?
Sunday.
Sunday.
Today.
Sunday. Right. This coming week. Yeah, and everything will be back, and I'll start shipping out replacement boards if people have got issues. So
I haven't tested mine yet, so
I'm sure
I'll
they'll be
fix
bad.
them.
They'll
I'll
be
fix
bad.
them myself.
They'll be bad.
Yeah.
And the other thing, it occurred to me this morning, like one of my patrons actually said, just tell me what I need to do and I'll fix the boards. Like if anyone wants to fix their own boards, and they've got a hot air station or tweezers or whatever.
It's a simple thing.
Yeah,
it's
it's
just doing them on 1200 is not
Yeah.
quite. Yeah.
Yeah.
Well, getting the parts. is
And getting the
problem.
parts, right.
Yeah.
So,
Yeah.
So they're unusual capacitors or inductors. The ones, unless you do RF kind of antenna matching,
Right.
you wouldn't probably have them.
like I spent, well no, in the case of the Tiny S3, sure, but the other ones are just zero.
Zero, yeah. So you can do that with
Yeah,
a
and like I spent
small
$1,000 on Thursday on just kits of RF, like, inductors and caps. Like $1,000, bang, gone. Like,
Just
you
to be able to
have the whole
experiment with
range,
different
right, that's
elements.
right.
Yeah.
There's nothing worse than, what if I tried a 5.1 picofarad?
Don't have one.
Yeah, and you can combine caps and resistors, but it's become really impractical when you're dealing with 0402 parts, and you've got almost no space
Right.
to do it in.
Yeah.
Yeah, and you're dealing with RF, so you've got to make sure that you don't add any little stubs of solder or
That's
anything,
right.
'cause they can.
It's not like you can run leads out to a larger part or anything. It's just, yeah.
Yeah.
Or stack resistors on top of each other to build a tower. Yeah.
So, Kean, since you're driving back to Sydney, you look like you had a question.
I was going to say, what have you been doing?
What have I been doing?
That's what I was about to ask.
Buying windows.
Yes.
Buying windows. Right,
Yes.
yes, you tweeted about windows. Yep.
So
You
you
mean
knocked
windows
out the
for
wall.
your...
Yeah, for the glass wall between the lab and the clean room.
Oh, that one.
Yes.
I thought you meant windows for the
Front.
when you're getting ones that go into the cool room panels.
Yeah, well, that whole wall, I think, is going to end up just being a glass wall.
Okay.
Oh,
So-
okay.
Yeah, my original idea was that I would just have a door and a window to look through,
Right.
and
Yeah, all glass. Make it all. Let
it
everyone see.
is. It's going to be all glass.
Yes,
So
it's not too
I
expensive.
bought them yesterday. Went down to a place. So basically, what I've got is an aluminium framed sliding door unit that is what you would have like on a back door out onto a patio.
Yep.
Right.
So fixed panel and sliding door.
Yep.
And I've got, or is it? I can't remember. I think it's fixed panel and sliding door and 2 panels or something like that. And I bought 2 of them, one in a left-hand configuration, one in right-hand.
So you can-
So I'll just butt them up. There'll be a frame in between,
Yeah.
but
Oh,
still.
no frame and sound effects. You got to do it. Come on.
Yeah. So the 2 units. So the standard width of the units is 2410, I think, like 2,410 millimeters.
Okay.
2 of them stacked comes to 4.8, which is it's like 20 millimeters longer than the gap between the 2 pillars. So it's going to go probably on the front of the pillars,
Yep.
and it'll just be like wall-to-wall
So
glass.
those central bits of the frame, you probably don't need them once you've bolted the things up
Attached to
top and
everything.
bottom.
It might be possible to modify.
Because it's not. It doesn't need to be it's not a security door or anything.
No,
it's an
it's
internal
internal.
door.
Yeah.
You just want to kind of. And
You
it
know what's
doesn't
going to
have
happen? Like you'll all the time. You'll just be
Walking
fine.
straight
in and out.
But that one time when you're holding a panel,
Yeah.
that's
and it catches.
it's not reflowed yet, and all the parts are on. And as you're walking through one thing, you knock your elbow on that center element thing, and it's all over all the parts on the floor.
Yep.
Yeah,
That'll happen.
Get a saw.
One day.
You cut that.
Yeah.
It's even more annoying when you do it a second time.
I tell you a funny thing I did. Sorry, just
Yeah.
we'll get back to the windows in a second. Is when you're pick and placing a board, and you got the oven on, and you turn the conveyor on, and that's going, and you forgot to adjust the conveyor width, and so the board comes out of the pick and place and goes onto the floor. Bang! It hits the ground, and all the parts go. Yeah, 890 parts,
Oh.
all 0402s.
The whole panel.
Yeah, the whole panel destroyed. Just because you forgot to turn the. Yeah. Don't do that. That's not fun.
No.
So, a whole entire length glass wall.
Yeah.
Are you going to be able
And-
to keep it still temperature controlled?
I think
Will it be
so.
sealed?
Yeah.
Yeah.
And you want
that's
to have
actually one of
positive
the
pressure as
advantages.
well.
Yeah, just a little bit. It doesn't need to be a lot. I'm not aiming for, semiconductor fab clean room sort of thing here. This is just, I just want to
Clean
have,
room.
yeah, I just want to have less dust in there than
Like,
elsewhere.
not pop your ears and
Yeah,
block your own.
exactly.
Yeah. Okay.
So
You're not
the-
going to put on the bunny suits.
No, not quite that far. But the nice thing about those patio door closers is they've got weather strips in them. So basically you close them and they're almost airtight.
Okay.
So it should work out pretty well.
Cool.
And yeah, they're being delivered on Tuesday.
Okay. Have you worked out what you're doing with that other door on the side? Are you still going to cut into the concrete?
I haven't. Oh, yeah, that's going to have to go through the concrete.
Okay.
Now that I've bought these doors that go the whole width, I can't do the little dogleg thing anymore. I'm going to have a hole through that wall.
Okay.
Yeah. So Lachlan seems to be okay with that idea.
You just gotta put in the
cement
lintel.
saw, and yeah, there'll be a steel lintel across the top.
That's because it's locking you into a 100-year lease, right? So,
It's mine forever.
yeah, you broke
Yeah.
it. You
I broke it.
Yeah.
Yes. So I was thinking of. So the more I think about this, it's a bit of a. It's like both a blessing and a curse that this has all been delayed, because the longer it goes on, the more I think about it, and the more ideas I get from people,
Sure.
the better it gets. But of course, it's frustrating that I haven't actually got it all done yet.
Yeah.
So what I'm thinking of doing now is, now that that whole wall is going to be glass, I might paint. There's only going to be a little strip around it, and I think I'll just paint it all black. Because originally what I was going to do was you get white framed doors, and when I went to the door place yesterday, they had black frame ones as well. And I looked at them and went, that actually looks really cool.
Yeah.
So what I'll do is just paint out the rest of that wall black, so that when the clean room behind it, which is going to be 100% white, like white floor, white walls, etc.,
And well
with
lit.
the lights
Really
on
stark
and well
contrast.
lit, it'll just be like looking through into a bright white room, and then
Like a laboratory.
Yeah.
yeah. So hopefully aesthetically,
I have
it
to
will-
keep it clean then.
Yeah, I'm going to have to. Hopefully aesthetically it will work out okay.
Can't wait to see it.
Yeah.
Yeah.
So it's in terms of cost, the whole glass wall has cost $1,900, which is it's a significant amount, but it's actually less than I had thought.
Because they're standard size.
Yeah,
You're not getting custom made ones.
No, nothing custom made.
That saves a lot of money. Yeah.
So yeah, they were only they're $900 and something, $950, including GST per unit.
Yeah.
All ready to go, and they had like a row of them sitting there in the shop, and I said, "I'll take one left hand, one right hand."
But aren't they supposed to be mounted to something above as well? Like
Yeah,
something
the wall-
structural?
Put a
there'll
beam
need to be
across.
Right.
some framing above it as well.
Okay.
So there is a gap. The height of the door units is 2.1 meters,
Yeah.
and the ceiling in there is actually more like 2.7 or 2.8.
But
So
you
there's gonna
were
be
going to only be doing the cold wall stuff.
Yeah.
To a
Wasn't,
certain
wasn't going to be anything structural
No.
to hold, but now you're going to have to build something at least around
No.
that.
Well, it doesn't need to be all that structural because the aluminium frames are pretty well self-supporting. They're going to be attached on the walls at the sides, on the
Right,
bottom,
okay, yeah.
and
Sorry.
the top will kind of it could flop around, but it will still be attached to a stub ceiling, a stub wall that'll go
Okay.
across the top.
Yeah, I forgot it was attached
And
to
you-
the second side
yeah.
as well. Yeah.
And that wall, you're going to use that wall where the fire extinguisher hose is.
Mm-hmm.
You're not going to put another false wall in front of that.
No.
No. Yeah.
So that fire extinguisher is just behind a big cement block pillar, and I'm going
Yep.
to fix the glass on the front of the
Yep.
pillar, which means that access to the fire hose is going to be excellent because you can just slide the door open and the
That's
fire hose will just be right around the corner.
Yeah. That's cool.
Yeah.
You're going to spend
Fun.
5 hours every week cleaning fingerprints off the glass. Has everyone seen the
I'll get one of those window cleaning robots that.
Yeah. Ones they use with the fish tanks, you know, the magnet.
Oh yeah, yeah.
The double sided.
Straight and swipe it along. Yeah.
Yeah.
Wagon Load says, "Are they sliding patio doors?" Yes, basically. Yours sounds like the Severance office. What's the Severance office?
Oh.
Do you know what that is?
Severance, you know, the show on Apple TV?
Apple TV.
No, I haven't
Severance?
seen it.
Oh my god. Best show. It is, seriously.
Okay.
But anyway, the office is just all this bright white.
Oh, yeah.
It's just, yeah.
I'm going to have to watch it.
Yaz and I are just hooked on Severance. Like, it's every Friday night, a new episode comes out. We're watching Friday night, and we're both like, and then the episode ended, and I just called out, "What the fuck?" And you just went, "Oh my god!" And the biggest cliffhanger, they just stopped it on, right?
Yeah.
Oh, such a good show.
Okay.
You gotta watch it.
Okay. I have not the faintest idea about what it's about, other than the fact that they have a white office, and it's called Severance.
Doesn't give anything away.
No.
It's this thing where that you can, when you go to work, they sever your brain between your outside of work life, your outies, and your inside of work life.
Sounds awesome.
So when you're at work, you have no idea who you are outside.
Oh,
You only
okay.
remember and know what happens at work.
So it's different. It's a context switch.
Yeah, compartmentalising, right? And so people are doing it because they've had trauma in their life or whatever else, and they want to be able to function at work.
Or
and
run
they-
their own business.
trauma in life.
And yeah, that's the premise of the severance bit, where they sever their memories between the two. They're like two
Okay.
people,
Yep.
right? But it's bizarre. It's just
Okay.
so bizarre.
Okay.
And it's
This sounds intriguing.
yeah, you got to definitely watch it. You got Apple TV, folks, like
Yeah.
Apple TV Plus.
Go and
watch
check
it.
out Severance.
Changing topics.
Yeah.
Pick and place.
Yes.
Have you done anything with your machines?
No, they're still
No?
waiting for the space.
Okay.
They've sat for months now with
Yep.
tarps over them and things in.
It's white as inside.
I can relate. Yeah. Because the Charm High, I built a bench for it. I've given it pride of place in my factory, and I haven't.
Now we get it working.
I've run through a whole bunch of tests on it, and there's one of the valves, air valves, is sticking. But otherwise, everything seems to work great,
Yeah.
but I haven't been able to get it to accept any of my data files. So I'm doing something wrong.
It's finicky.
And the error messages I get do not help.
Well, it's-
It just says,
For those that aren't aware, Kean's got my charm high. It's-
Yeah.
And I'm not regretting it yet.
Not yet. So I was actually planning on going to Electronics this coming week.
Yep.
And
Up in
so,
Sydney, I think
yeah,
it is,
originally Kean was coming here, and then I was going to go up to Sydney for like a week or so, just hang out. And I was going to help Kean try to work through the charm high thing. I actually cannot remember anything about it. I mentally blocked
You need
out
therapy.
everything, right? I'm going to have to work it all out again. But yeah, it turns out I can't get up there, and then it sounds like half the vendors aren't even going this year. It's going to be a pretty small show, yeah.
Yeah, I'm going to try and go. I'm going to try and meet up with Mick.
Well, I'm going to go meet Mick, and we're going to get a group together, get Dave and whoever else. But yeah, just other priorities, unfortunately. So do you have a move-in date yet?
Well, I have the key. So technically I now have
You've taken possession.
possession and I can start doing things. And I've just started patching little holes in the cement floor.
Okay.
The previous owner of the factory, so we're talking 40 plus years ago, Lachlan's had it for 40 years, had some kind of internal partition walls and they'd nailed straight into the cement slab. So when they pull it out, there are these little holes all on the floor.
It's shattered bits of
Because they
It's
use
shattered
the
bits of concrete.
explosive,
Yeah, exactly.
things,
Explosive
Yeah.
nails. And so I've done a bit of testing with some cement patching compound, and it works really well. It comes up with a very hard, it bonds really well.
But can you see it though?
So-
Like, is it visually? Is it?
At the moment you can see it because it's just on bare concrete.
Right.
Yeah.
But then once it's all paving painted, it should be fine.
Yeah.
Yeah.
So you're going to paving paint. You're not going to do any type of ESD treatment on it.
Put mats down.
Matt? Probably paving paint first to seal it.
Yep.
But then there's a question of, do I just leave it as paving paint or do I put something else on top of that?
So the ESD treatments you can do on it, really expensive.
Yeah, the epoxy.
Yeah.
stuff
And you're better
is
off-
Very expensive.
You're better off just having some mats. Like you can get expensive mats for floor because they're a bit more rugged,
Yep.
but your usage is probably not going to be.
It's very light.
You're not going to be that hard on it.
You want to, at the entryways, anywhere where you move into the room and
Yeah.
back out of the room, you want to make it so
So
you
that it
cannot
dissipates.
avoid standing on the mats.
Yeah. You've got to be coming in contact every time you
Yeah.
go to a machine.
Multiple steps. Yeah.
Yeah,
Yeah.
so my pick and place is on a bench with a mat, and there's a mat going across to it.
Not that ESD exists. It doesn't exist.
It doesn't exist, no.
Iggy said it didn't exist before. And
Yeah.
You
Oh,
trust
I'm sure.
everything that Iggy says.
Iggy always says ESD doesn't exist.
Yeah.
He's constantly on that.
There's just this thing that keeps zapping you
Yeah.
when you walk across the room.
So something like this is dissipative.
Yeah.
So just it's only meant for benches, but something like that on the floor should be okay.
Yeah.
No, you'll just destroy it. Like walking on that and whatever. You need to get something that's designed to
That's
be walked
really
on.
thick.
I think that would be okay, but
Really?
yeah. So you,
You want to replace it every 6 months?
Probably
Get
not.
the thicker mat.
yeah, that looks a bit cheap, that one. But
No, it's designed for a bench top. Like
Yeah,
you want,
yeah.
The ones that you're
designed for a
standing
floor.
on,
From-
whatever, they're like
you can buy it from
90 millimetres or something.
Metronics or Oritech or one of those. I bought a bunch of 10 metre lengths and then cut them, and then you buy the little snaps that you
Oh, right,
yeah,
yes.
that you can connect to. I don't know where you got this stuff from.
I can't remember. I ordered it from somewhere in Sydney.
Yeah.
Yeah, I got mine from Electronics.
It's the same place Dave Jones got his.
Okay.
He did a video about it
Yes.
some years ago.
Discolouring.
Yeah, the discolouring thing.
Yeah.
And I ordered the same
Mine's-
stuff, but I
mine's
just ordered it in
gold too.
grey. So
I did in grey as well.
Yeah.
I didn't
I've got
want- The blue looked good, but I didn't want it to discolour.
Yeah.
But my grey's also
Yeah.
not as much, but from the direct sunlight,
It has
it's
a little.
Yeah, quite a lot. Yeah.
I've noticed mine is discoloured a bit where I've had multiple layers. Because what I do is I've covered most of the bench with a proper piece, and then I've got sacrificial pieces that I just sit on top so that you can just replace it if necessary
Yep.
with offcuts and things.
Yeah.
And then when something has been sitting there, so this dissipative surface has been on there for years now, and if I move some of those things away, there'll be a slight discoloration under where the other piece of mat has been sitting on it.
Okay.
But it's not terrible.
No. It's
Look, I still think the benchtop stuff is probably going to be fine for your usage, even if you have to replace it every few years.
Yeah.
You should have it on the benches, obviously, as well.
Yes.
Yeah.
But you've just got to get into the habit of touching touching it before you go and pick something up.
Yeah, or to touch the pick and place machine, like the metal chassis.
Yeah, which
every
is
time
grounded.
you walk up to it. Yeah, like that's what I do now. Like I just whenever I'm walking into that area, like if I walk up, I touch I grab onto the pick and place machine and walking.
I prefer to touch the mat because there's a high resistance, and so you won't get a sudden spark if you are
I don't
charged
have
up.
a mat though. Anywhere near, I don't have any bench space anywhere near pick and place. Right.
Yeah.
But yes. If I'm going to get a zap though, I'd rather get a zap when I'm not
Into the
holding
metal
the board.
metal case of the pick and place is probably fine. You just don't want to do it near a circuit board.
Yeah. Or as you're trying to put a board into the oven, zap and throw it.
Yeah. So like my office space is carpeted, and so I just have static mats. I don't have any static mats on the floor. I've just got them on all the benches. And I just get into the habit of touching that before picking everything up. And if I'm carrying PCBs around the office, I put them onto either I've got a lot of those MDF boards that come with the stencils.
Oh right, yeah.
Yep. So I use
with
them
lots of little holes all
with all
over
the drill holes in them. Yeah.
Yeah.
Or I've got a hold of the black plastic ESD storage boxes.
Yes.
And I use the lids from them, which are obviously dissipative.
Yep.
And so I, carry boards around with them.
So I just use my hands.
I've never had any problems apart from those LEDs.
Yeah.
Which was the factory in China.
Yeah.
Because I soldered heaps of them myself. Yeah. Never had a problem.
I've tried to figure out the sprays you can get for the carpet, and they do actually work. But like they say that respray every 6 months. And it's more like every month you got to respray. Like it really doesn't last as long.
You can buy a little device. It's basically a very high resistance measuring device. It's got 2 copper plates on the back, and you put it down on the mat or whatever, and it'll actually tell you the conductivity.
Interesting.
And so I got one of them recently because I'm interested, because I've got the anti-static chair mats in a couple of my desks because I don't want to wear the carpet, because I have the 3 places that I sit.
Yeah, you're in
3 different desks where I sit.
Like on my floor here.
You sit there for hours at a time.
Yeah.
And whether I'm doing programming on one desk, whether I'm doing testing in another desk, or doing prototyping, soldering on another desk. So I've got those mats there, and I've sprayed them with that same staticide or whatever it's called. And I'm interested in doing that measurement to see whether it actually does make any difference.
I think it does, because my experience, I'd go up to my 3D printer all the time and I'd get a zap just touching the frame of it, right? And that completely stopped when I was spraying.
Well, it depends on the time of year, because obviously
it's very
colder weather, the humidity you don't notice it, and it's low humidity. Like Antarctica is terrible for static.
Yeah, because it's so dry.
And the winds and so forth. I've got this other spray. It's kind of like a clear lacquer, and it's conductive, and very very high resistance, but it's conductive, and so you can spray it because obviously acrylic's not particularly good.
No.
Because it can create static. So sometimes
we all use it to make really cool fancy things for electronics, but it's really bad.
So I coat some of the things I make, like test jigs, with that stuff, and then I have metal standoffs and stuff, so they carry any discharge back through the USB connection. So there's at least a way for that to drain. But it's always better just to have the mats and avoid touching things until you...
I thought about ripping all the carpet out of my office and it's just yellow tongue underneath, but then putting down just some, the fakey floorboards, and at least removing the carpet from the equation. The thought of emptying everything out of my office would... What?
It's not nice doing that.
I'd rather that than zapping things or potentially zapping things, but there's no way I'm emptying my office of stuff. If I empty it all out, I'm never putting it back in again. I'm just going to put it on my note, just take what you want, everyone.
Well, this is a question I'm going to have for my lab area as well. We've been talking about the clean room, but then what I haven't yet resolved is what I'm going to do on the floor in there. At the moment, there's really crappy old carpet. It's like 40-year-old carpet, so I've got to pull that out. Underneath, it is a really smooth concrete slab, very nice finish. And I could paving paint it. I could put down vinyl or something similar. I could carpet it.
You get noise, if you're going to do streaming from there, you really want carpet, because that makes a huge difference in terms of...
Or rubber.
Noise.
Put down rubber, the gym type stuff. Like if you don't want to go carpet.
Yeah.
Carpet's lovely, no problem, but it's just not a good thing to have in a space where you work with electronics.
I notice like the carpet in my office upstairs is like really thin. It's a square tiles and it doesn't have really anything under it. It's straight onto straight onto concrete. But I notice a difference standing there compared to standing for a while in the warehouse downstairs, which is just the painted concrete.
Yeah. Standing on concrete all day sucks.
Bad backs, sore knees. Yeah, you really notice
sore
it.
neck.
So just even the minor carpet
just
upstairs
a little
makes a
bit
difference.
of padding.
Yeah. Or get thicker padded shoes, like Willie. No, seriously. Like,
I've since I had my back surgery,
right.
I now wear different shoes. It makes a big difference.
Yeah, you don't realise just how like it creeps up on you, and then all of a sudden you've got like chronic back pain from the concrete. I know. I used to have polished concrete in an old office, and you're right, it's louder and whatever else. Not really great with the wheelchairs, but so nice. Like it's just.
It looks good.
It does. It looks great. Cold though. Like it's
Stephen. Bare stainless steel sheets is actually bad because you don't want something that's directly connected to earth. You don't want metal surfaces. You actually want something with a resistance.
Yeah.
So you normally have a 1 mega ohm resistor between the static mats and the earth.
Yeah.
So you don't get a spark. You get a slow discharge.
Yeah. So it bleeds away.
Yeah.
And of course, on something like an electronics bench, you can't have anything conductive because if you've got powered up boards sitting on it, short circuits all over the place.
I don't know if you guys work with main stuff.
Yeah.
I avoid it if I possibly can.
I design some stuff. I don't have a choice. I try to avoid it as much as possible, but I do have to design stuff that's mains powered, and that's actually a safety issue. So you don't want a direct earth. The only time I ever have a metal plate that's directly earthed is when I'm doing EMC measurements, because you have that solid ground plane under that, and then I'm doing everything with. I've got medical grade earth leakage detectors, residual RCDs, and I've got an isolation transformer because you need to use the isolation transformer when you're using a listen to do conductive measurements, because the listen has these massive inductors in it, and that causes leakage, which will actually trip the RCD. And I've also got a generator that generates pulses, like surges and things like that on that mains.
Okay, so you can simulate noise.
I've got AC. I've got a couple of different AC generators, but this one's can like do fast pulses and stuff like that, and that also will trip an RCD when you're doing testing it. So you've got to have it on an isolator.
Yeah.
So safety becomes really important when you start working with mains.
Yes, it definitely does. I try to avoid it whenever I can. Like I mess around with sign-offs and those sorts of things, but I can't stand it whenever I have anything that's mains powered, uncovered, sitting on my bench turned on.
Yeah, it just freaks me out.
Yeah. Like, I'll connect everything else without the mains even plugged in.
Yeah.
It's not enough to just have it plugged in and turned off. Like I won't have it plugged in.
Right.
Yeah.
So while I'm working on anything, and then plug it in, hands off, and turn on the power.
Yeah. So what I typically do is I modify it so I can run it off DC power and hack. You know, if it's like some of my circuits have mains fail detection because they're battery powered, and so they're actually monitoring the pulses, 50 hertz pulses or whatever. And I've got other devices that I work on which actually use the 50 hertz or 60 hertz in America for timing, for synchronizing LEDs and stuff. Yeah. So one of my other clients does pool lighting with the fancy colours, and so all the pool lights are actually synchronized off the. So they all play the same pattern,
but off the power
because they're synchronizing off the power. So I've got generators for generating like different frequency mains at different voltages.
For the 50 hertz or 60 hertz, depending on the country.
Kean's got everything. You think about it, you name it, he's got it. At least 5 of everything.
He's been doing it for a while. Lots of time to.
I tend to buy, like in the case of the VNA.
How many VNAs have you got?
I think I've only got 3.
Only 3.
But they're all cheap ones. Like one's a Kickstarter one, one's the cheaper Chinese antenna analyzer, and then I've got the Nano VNA. And with the spectrum analyzers, I've got some cheap. I just tend to acquire things cheaply when possible. So like the Charm High and the other pick and place I got them both quite cheaply. And and then I put the effort in when I get a chance to get them to work.
Yeah.
So I've been fortunate in, like, I've worked with a number of companies doing mass production, and they'll often have leftover components, and they'll
like
give
the
them
end
to
of a
me.
reel or whatever.
Well, I've had, like, I got like 100,000 LEDs, white LEDs, because the customer that was building lighting no longer uses that particular LED because there's higher efficiency LEDs now. So I actually use them for building prototypes and verifying, circuit boards before putting the more expensive LEDs on. And I can build my own lighting panels. I've done a few, but I'm planning to build a whole lot of lighting panels.
You should build a logo. I expect to make a logo.
These are just white though. They're not quite as exciting.
Yeah, fail.
Yeah.
Yeah.
But I got massive amounts of through-hole, like headers and stuff. The standard headers and things from a company that was just cleaning out their warehouse. And I'm just going to throw them in a bin. So I just got boxes and boxes of them. So whenever possible, I try to do that, and I use all that stuff for prototyping. But obviously, for anything that goes in production, I always buy parts. Yeah. So I know that I can get more of that particular part from DigiKey or Mouse, and I can put them on a bill of materials to give the customer if they ever want to go to a contract manufacturer.
Yeah. Well, that brings up something that I might mention in a second, talking about getting stuff because an opportunity comes up. But I wanted to ask you about so you're going to buy a VNA, or what are you thinking about?
I was going to buy it yesterday, but I got I'm getting a visit by someone, like an absolute RF guru, on Tuesday. He's coming past just to go over everything again.
Okay.
To clarify, like, my thought process on stuff, right? Get and have a look at the chart from the pre-cert and whatever, and just to make sure that I'm
on the right track.
Yeah, on the right track.
Before you spend a whole bunch of money on something that may not actually help you.
Well, it'll help me. Like, I'll use it.
You want to have that equipment for going further because you're going to be doing more products, hopefully.
Right, and so the key about this is it's a VNA, but it's also a spectrum analyzer. It's not a separate thing.
Yeah.
So I get the benefit of a better, reliable VNA that doesn't have to run off my computer. Right, it's proper processing, and a spectrum analyzer to be able to do the EMC stuff if I need or as I need. Right, so they're just tools I need to have. Like I've avoided them for long enough, and I probably should never have gone as far as I have with RF without having better tools. But now that I'm looking at putting my boards through certification, at least CE, but I've got a customer that is pushing me, like, is actually offering to help pay for also putting all my boards through FCC.
Okay.
And my boards don't need FCC. It's not a requirement. They're sub-assembly. But
that's that's going to change.
Sorry? Yeah. Well, there's some stuff happening with Amazon now and other things where they're, maybe through their own ignorance, not real, because of the CE and the red stuff, that they're now making anyone who sells anything, where's your certification? Even though it doesn't need it. They're causing problems. So, I think I'm gonna have to do it. And it's not like a oscilloscope that you use often. Like it's that's what stopped me in the past, right? It's,
Every time I do RF stuff, I've got to kind of go back and think through how am I doing this? What are the steps I've got to set up? Especially if you're doing EMC measurements, because you got to set everything up in a consistent way.
Sure.
And you don't want to blow up your spectrum analyzer by feeding
Well, that's what we're doing.
Feeding too much into it.
Yesterday we were going through, looking at all the different attenuators and looking at DC blockers and looking at can I show you something hilarious? So Kean's I'm trying to focus on what do I need to solve this problem.
Yeah.
And Kean's trying to talk me through the whole way dB and dBm and it could be halving, or you could be doubling in 10 times and all the different and he's going, and so this is the thing I'm going, I lost it again. He's going, it's like this and I'm going,
I had it for a moment there.
I just couldn't do it. I couldn't retain anything he was saying, and he kept trying, he kept rewording it, go on, you Kean, he really kept going. All I could focus on was, how do I test this thing? What do I need to buy for this thing to test this thing? It's pretty funny.
You'll get there.
I'll get there.
You have to.
Yeah. I have to,
There's some really good videos on YouTube these days.
Yeah.
Kind
The
of
problem
going
is
through
most
that
of it's relevant, but it's suited towards amateur radio, right? So it's hey, we're going to show,
That's
we're
so
going to tune a
relevant.
network,
Yeah.
and we're going to do blah 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 blah, and of course they're working with all this big equipment and a completely different type of
and a very different frequency,
and everything else, right? But all the general stuff like impedance and matching and reflection and standing wave stuff and whatever. Like I've been consuming a lot of stuff.
Yeah.
But like for me, if I can't visualize it, that's why I couldn't get the DB stuff, right? I need to visualize it.
But if you're going to start doing measurements, you need to have a clear understanding of DB.
Right.
So that's your next step before you actually start doing anything serious with the real testing.
But for me, I can't learn it from reading, right? Or having someone tell me. I need to visually see it. Like I need to be able to plug this in and go, oh, that's what that is.
That's why I was saying it's good to have those extra cables, and you can actually do, like once you've got the spectrum analyzer with tracking generator, you can actually run tests on, like you can buy a 6 dB attenuator, and you can actually measure that 6 dB attenuator and actually see how it actually works with frequency. Because no component is going to be perfect.
No, it won't be a flat response. There'll be variations across different frequencies.
That's right.
Yeah.
And the higher the frequency, the more variation it is.
But like my pigtails I'm using from RF, right? I think they're HA405. Like that's what I bought, but I can't confirm they are.
You've got no way to measure it,
right?
Well, you do. You've got a VNA.
Sorry?
You've got a VNA. You can measure it.
Right. Anyway.
But again, when you're talking about really short pigtails at 2.4 gig, it's not a big deal.
Well, 10 centimeters. That's.
So I was looking at some cable,
size.
like some really expensive cable, like sold by the same people as that VNA.
Yeah.
Just to see what cables they sold. They had an $800 cable. It doesn't say how long it is. It's rated for 115 gigahertz. Okay? And then you look at the specs, and at 30 megahertz, it loses, I can't remember, it was a few dB per 100 meters.
Right.
As you go up in the frequency, like the loss per 100 meters of cable is like
massively.
Wow, like you at 115 gigahertz, and like I didn't even think you could use coax at 115 gigahertz. I thought you had to use waveguides and stuff. But it was like 155 dB loss. Like,
is that even a thing?
Yeah.
That's a crazy number.
But typical spectrum analyzer may only have 120, 130 or something dB of dynamic range. So unless you've got amplifiers in there, you can't actually measure it.
You can't even detect it. Yeah.
But 115 gigahertz spectrum analyzer, I don't know if you can buy it. I know Keysight have these really high-end ones. Sharia, I don't know if you know Sharia.
Oh yeah. The signal path.
The signal path.
Yeah.
Like he does stuff with really high-end test equipment because he does the 6G stuff, and like some of that test equipment is like astronomically expensive.
Well, he was doing videos on the Siglant that I'm looking at getting.
Right.
Like he's got some videos on those, which is pretty cool. It's like, okay, what else do I need? Here's the VNA. What else do I need? Okay, you need some calibration things.
Yeah.
$700 fucking dollars. Sorry, $700. But it's a 50 ohm resistor and a short and a open SMA connector. That's it.
Yes.
$700.
Once you start getting into cables and all of the other add-ons, you look at the price of the test gear and you think, I can stretch to that, and then all of a sudden it's
No, calibration.
That's just the beginning.
Can be
I know.
thousands.
It's ridiculous. Like, and I've not even started on the EMC test stuff that I need to get. Like that's the next step. Near field probes and like really good that and other cables and other things I'll need. I don't know if I'll ever go to the word of getting a listen or anything else because I don't do that type of power connected stuff.
Yeah.
But maybe one day, I don't know. It's just the whole thing is just it's a money pit. Like it's such a money pit.
No, so unless you've got circuits with switching power supplies and drawing lots of current, you generally don't have issues with conducted emissions.
Yeah.
So radiated emissions is the big for you.
Yeah. I know. But like you know me. Hey, I'm just going to put together build a power supply.
Build some other
and mass produce it. With no thought at all into testing. No, never happened.
Yeah. Well, we are pretty much out of time.
Yep.
Right, you said you were going to say something.
Oh yeah,
What were you gonna
okay. Just a little teaser. This is something that's worthy of
Teaser.
yeah.
Yeah.
This is something that's been in the works for a little while.
Oh, that's a big box.
But I haven't said anything about it. So Nigel has organised. There's a whole backstory to this. These devices, it's a pack. I don't know if people can see that. This is a pack that comes with two. This is all Z-Wave.
Okay.
So 2 6-port power boards and 3 single plug sockets. It's like a son-off.
Right.
It also comes with a gateway and like a Z-Wave gateway and a display. And the idea is you put this in your house and measure power usage of devices around your house. And these were left over from a project years and years ago, like 12 years ago or something. And they've been sitting in a warehouse, taking up space for all of that time. And it got to the point where, and the thing is that these gateways are no longer supported, which means you can't even just give this kit to someone and have them use it anymore.
Right.
Because they need a cloud connection or something.
They need, there's some cloud service that these things don't work with anymore. So they've had pallets of these things sitting in their warehouse, and they were going to destroy them, like actually pay to have them destroyed.
You're going to retrofit them all?
Yes. So
Excellent.
So Nigel organised to have them donated to me. So I now have
How many?
218 of these kits.
Wow.
So basically that means 400 power boards.
This is power board alone.
And 600 of the single sockets.
Yeah.
And I've got them working now with Home Assistant.
So these were on the market at some point?
They were on the market.
Okay, so they've gone through the safety certifications.
Yeah, they're all certified and everything.
Yep.
Yeah.
So you just going to need to like look
So
at
all you need is your own
firmware?
Z-Wave. No, it doesn't even need any firmware changes.
Okay.
It just needs a Z-Wave gateway,
Okay.
which can be integrated with something like MQTT or Home Assistant.
Yeah.
And I have one. So down in the corner of the room down there, you can't quite see it. There is a Raspberry. Oh no, I moved it. It's up there. That thing with the green light and the USB stick hanging out of it. That is a Raspberry Pi with an AOTech Z-Wave stick, and that's running Home Assistant. And with that, I can integrate these things and.
So this works as is.
As is.
Wow.
So I'm going to, my plan for the new lab, well, for whatever's left over. So my plan for the new lab is that I'm going to get these 6-way power boards and basically mount them under the bench pretty much all the way around the room, so that I've got heaps and heaps of sockets, and every socket is individual power controlled and power monitored. So I'll be able to see exactly how much power is being used by every device plugged in.
Nice.
Wow.
Yeah. So
talk about over-engineering your office.
That's what I need for my office. Like my power bill was like horrendous.
So I've got pallets of these now at the factory, taking up a large amount of space.
That is so cool.
So yeah, I've been making trips during the week. I made 3 trips to AusNet's facility in Ringwood, in Heatherdale Road. They've got a big place down there, and went down with a trailer and loaded up pallets worth of these things and took them over to the factory.
Awesome.
That's so good to be able to do that rather than having going.
Yeah, they were just going to be destroyed.
Yeah.
So everyone, I'm making a prediction. In 6 months' time, John will not be working out of his new lab, but he will still be tweaking and setting it up. It's now a project rather than a tool. And it's going to be the best fitted out project ever.
That doesn't ever get used because it's never finished.
That's right. Yep, I'm predicting it now.
Okay.
No, that's really cool.
I think Seon's right.
I thought you were going to say that you're going to have to like take the little box and then retrofit that to get it working, but you didn't even need to do that.
No, I don't even need to do that.
Wow.
So Z-Wave is something that I haven't done anything with in the past. I've done a bit with Zigbee and a few other things, but Z-Wave being a proprietary thing made only by Silicon Labs, it's just never really come across my radar. Like, I've known what it is, but I've never had equipment, I've never bought stuff for it because it's a whole extra system of radios and software and things. But when Nigel said, hey, I can arrange to have like several pallets of this stuff donated to you, I was like, oh, okay, I better pay attention to this.
That's really cool.
So, yeah.
Yeah.
Very cool. So, I think it's about time that we wrapped it up.
Yeah.
Yeah, what is it? It's
It hasn't been that chaotic.
No, it hasn't been that chaotic.
It's been fun.
Yeah, it has.
Yeah.
Thank you very much for taking the time to call in on your trip down from Sydney.
Thanks for letting us.
Yeah, and
see
Seon,
you.
it's always awesome to talk to you.
Yeah.
Yeah. So, thanks everybody, and we will... Peter's telling you, he always does this. Every week he's like, go away. So, thanks for coming along, and I hope you've enjoyed this little chat. Have a great week, and we will see you all later.
Bye.
Bye.